Hello everyone, welcome to Tecme seminars. My name is Nicolás Ormazábal. It is a pleasure to begin with these seminars online. Welcome to all. Today we start in this seminar talking about the Tecme ventilators, and the idea is to continue with this seminar tomorrow and after tomorrow by talking about the ventilatory modes and the monitoring of our ventilator. So we invite you to follow us in this webinar and also tomorrow and the day after tomorrow. As I said, today we are going to talk about Tecme ventilators. Most of you know us, some of you know, so I will make a little introduction about our three products that we are dealing nowadays. First of all, we have the Nemovet Neo. This is a ventilator dedicated for neonates and infant patients. It is a ventilator that can achieve a tidal volume from 2 ml up to 350 ml. So it is a ventilator precise and dedicated for small babies and small childs. Also, it has the capability to measure the flow using a proximal flow sensor that is available in this machine. In addition to this, we have also the GraphNet TS. This is our second ventilator. This is a ventilator that, as a standard, is adult pediatric with a tidal volume from 20 ml up to 4 liters, but with the capability to add the neonate category as optional. So with this machine also, you will be able to ventilate neonates with a tidal volume nowadays from 2 ml up to 400 milliliters. And finally, we have the GraphNet Advanced. This is our high-end ventilator. This is our complete machine that is adult, pediatric, and neonate all in one, that has the capability to achieve up to 2 ml, up to 4 liters. It also has the volumetric amnography, and as the neonate, it has the capability to measure the flow by using the standard distal flow sensor or using the proximal flow sensor for neonate to be more precise on the measure. So basically, these are the three machines that we are dealing nowadays. And the idea of today is to talk about the ventilator description. So basically, all these description that we are going to explain in this webinar will apply properly to those machines. The idea is to begin explaining all the components of the machine. So the first part that we are going to talk is about the rear cabinet. In the rear cabinet, you will find the speaker. This speaker is going to give us alarm sound when a problem is appeared. So at any moment that an alarm is triggered, the machine is going to sound and warn the user that there is a problem that must be solved. This recommendation on this is needed to cover up, because if you cover, the machine is not going to give enough warning, and the doctor will not be noticed about it. Also, we have here the cooler. The cooler is a fan that is going to blow air inside the machine in order to refrigerate the internal component. If this cooler is not working properly, probably the inside of the ventilator will start to warm up. And if this temperature reach a critical level, probably the electrical component will get damaged. So as I told you, the same as in the speaker, never to cover up this fan, because if this fan is covered, we are not going to be able to refrigerate the internal component properly. Also, in the rear cabinet, we will have two connections. One is the serial port. With this serial port, we are going to be able to connect a laptop or a PC in order to do a software update. Every time that Tecme launch a new software, we are going to be able to connect the laptop and update this software through this serial port. In addition, nowadays, with this in this serial port, we are going to be able to connect our machine to a hospital information system. Nowadays, we are dealing with two types of protocols. One is the Tecme protocol that is properly, and the other one is HL7. In the last software version that we have launched, we have added this HL7, that is a standard protocol in order to be able to connect to the HIS. Then we have the VGA. The VGA is a video output. This will allow us to connect an external monitor in order to get the same screen, the same monitoring parameters in a bigger screen. Normally we use this in an isolated room in order to put an external monitor, and the doctors will be able to monitorize the patient from outside the room. Also, we have here the on-off switch. With this key, we are going to turn on and turn off the machine. Then we have the power, where we are going to connect the main power supply. Our machine nowadays is working with 110 voltage up to 240 voltage, so it has a switch power supply. So you're going to adjust automatically according to your main power supply. We will find here also the gas inlets. The machine to work properly needs air and oxygen. So these high pressure gases are going to be connected in those connections. One for oxygen and the other one for air. Also, the machine has an internal battery. The battery is inside the machine, and it is a battery that will give a power supply up to 2 hours and a half. So basically, if the machine lost the main power, the machine will start working with the internal battery, and if this internal battery is totally charged, the machine will keep working at least 2 hours and a half. If we go to the front panel, we will find, of course, at the center, the 12-inch screen. This is our screen in where we will show all the monitoring parameters, and all the settings are going to be done on this touch screen. Then we will find the rotary knob. This is the knob that we are going to use in order to change and accept and confirm different parameters that we want to set up. We will have some hard keys in order to change the ventilatory mode, in order to go to menu, alarm limits, and also to do different maneuvers. For example, to lock the screen, in order to lock the screen and avoid accidental changes on the parameters. We have the suction in order to suck the secretion of the endotracheal tube of the patient. This is a maneuver in where the machine will give a high oxygen concentration during 60 seconds. Then you will have a windows in order to do the suction of the patient. And after this period, you will have also a secondary oxygen, high oxygen concentration during 60 seconds in order to restore the oxygenization of the patient. Then we have the manual inspiration. This key, every time we press it, we are going to generate a manual trigger. So we are going to force an inspiration every time that we press it. Then we have the inspiratory pause in order to do an inspiratory pause to calculate the plateau pressure, or in order to do an expiratory pause in order to calculate the auto beat. Then control and escape key that are other function, for example, control in order to set more precise the sensitivity, and escape in order to cancel and go into the home screen. In the lower block of connection, we will find different connection. The standard for all machines are the patient outlet. Here we are going to connect the inspiratory limb in order to provide the inspiration through this port to the patient. Then we have the expiratory set, in where we are going to connect the exhalatory valve and the expiratory flow sensor. We have also as a standard the oxygen sensor that is integrated below this cap. Also, as a standard, the nebulizer. All our machine has an inbuilt nebulizer, a pneumatic nebulizer, a nebulizer that in adult pediatrics it is synchronized with the inspiration. In neonate it's going to work continuously, but in adult and pediatric it's going to synchronize the nebulization with the inspiration of the patient. In all categories, this nebulizer is going to also control the oxygen concentration that is delivered to the patient. So if I set an oxygen concentration of 50%, the machine also is going to deliver 50% of oxygen through the nebulizer. Then, depending on the ventilatory model that you have, you may find other connectors. For example, the proximal flow sensor that is available in the GraphNet Neo and also in the GraphNet Advanced. Here we are going to be able to plug this proximal flow sensor for neonate categories to measure the flow close to the patient. And then in the GraphNet Advanced, we will find the capnography. Here we are going to be able to plug our Capnostat 5 from Respironic in order to be able to monitorize the volumetric capnography. All Advanced has this volumetric capnography included. The only optional that is available is the sensor. The software and the connection is already installed in all machines. The only thing that must be purchased separately is the sensor, and it is plug and play. As soon as you plug in the machine will start to measure the volumetric capnography. Also, with this volumetric capnography, we are going to go more in detail in the third seminar that is going to be done after tomorrow. Before going to the startup of the machine, let me ask some questions in order to make some interaction with you about what we have seen right now. So now I'm going to share with you a poll. You will be able to answer, and then I will share with you all the replies. So basically, the first question is which type of patient you will be able to ventilate with the GraphNet Neo. So you will be able to reply. And the second question is which is the minimal tidal volume that we can achieve with the GraphNet Advanced. I will give you a short time in order to reply. So most of the people reply properly in two questions. This, let's say, a little bit easy. This properly replay is that the Neo, the GraphNet Neo, we are going to be able to ventilate infant and neonates. Adult and pediatric and neonate are going to be available as a standard in the GraphNet Advanced. Adult and pediatric as a standard in the GraphNet TS. The minimal tidal volume that we can achieve with the GraphNet Advanced nowadays is 2 milliliters. So we are going to be very precise on the delivery of tidal volume for neonates in the GraphNet Neo and also in the GraphNet Advanced. Okay, continue with the presentation. We are going to talk about the setup and startup of our machine, how we must connect our machine and which is the procedure that we must do every time that we want to set up and start the ventilation. At the beginning, we will need to plug the power cord. We recommend to keep it plugged even when the machine is turned off. So our recommendation is as soon as you finish the ventilation, to leave the machine plugged. This is in order to keep the battery, the internal battery, fully charged. So when the machine even is turned off, the machine will start to charge the battery automatically. So as soon as you turn on the machine, we will assure that the battery is fully charged. So remember to keep it plugged, the machine on the wall, in order to keep the internal battery fully charged. Also, another important is to fix properly the cable to the rear cabinet in order to avoid accidental disconnection. So always adjust this fix in order to clamp it. Then we are going to connect the high pressure gases. As we told before, we have air and oxygen. It is required to ventilate with our machine. They have this connector, the standard this is an international standard. And they have different type of connector for air and oxygen. So these connections are different in order to avoid accidental connection. To connect always oxygen in the oxygen inlet and air in the air inlet. In the air also we provide as a standard a filter. This filter is going to filter the air that is going inside of the machine. Even this filter is there, always we recommend to connect medical grade air and medical grade oxygen to our ventilator. These gases are considered like a drugs, so they must be medical in order to provide a properly ventilation to the patient. You have to consider that this gas that go inside the machine is going straight to the patient. So any problem or any water or oil that may be in the air go straight to the patient. So in order to avoid this problem, we recommend always to use medical grade air and medical grade oxygen. Medical grade air is oil-free and with zero humidity. The pressure that we must apply at the inlets, nowadays with the latest machine, it is between 2.8 and 6 kilograms per square of centimeters. If the pressure drops below 2.8, the machine is going to give a warning and will start to work with the other gas. Also nowadays, if the pressure goes up 6 kilograms per square of centimeters, it's also going to give a warning. This is an example of why it's so important to use the filter and use medical grade air. As you may see in the video, there is water coming inside the central pipe. And this water is being filtered by the filter that we provide in order to avoid that this water go inside the machine. But remember, even that the filter is there, we recommend to use medical grade air and medical grade oxygen. Then we are going to connect the circuit, the patient circuit, and all the interface. This interface will depend on the type of patient that we are going to ventilate. With our machine, as I'm going to show you later, why we are going to be able to use any type of patient circuit, adult, pediatric, neonates, reusable, disposable. The machine during the initial calibration is going to make an adjustment and is going to make a measurement of this patient circuit and is going to compensate the volume that remains inside. Then we will check the power supply. In the front of the panel, you will find two LED indicators. One that is going to indicate that there is, if there is a main power supply or not. If there is no power supply, this LED, green LED, is going to be turned off. And if the machine is working on battery, it's going to turn off the main power supply and is going to turn on the battery indicator. Always we recommend to use the machine plugged. The internal battery is for an emergency. Is in case the power run out, the machine will start to work on battery. So we recommend on the beginning, as you connect the machine and you start to ventilate the patient, always do it with the main power supply. Once we have set all the connection, electrical connection and pneumatic connection, we will be able to start the setup and the initial calibration. As soon as we turn on the machine, depending on the model, we are going to find the categories available in this model. Now in this example, I'm using the GraphNet Advanced, that is adult, pediatric, and neonate. So now I'm going to be able to select between these three categories. As it is touch screen, I'm going to be able to set by touching the screen or using the knob that is in the front panel. Once I have selected the patient category, I'm going to be able to set the ideal body weight and the rate of ml per kg that I want to ventilate. This is an important adjustment that I'm going to be able to be done before the initial of the ventilation. The idea of this is to preset all the tidal volume and also the tidal volume alarms in order to ventilate this patient properly. Once I have set all the ideal body weight and the rate of ml per kg, I need just to press continue in order to go to the next step. In the last software version that Tecme has launched, we have the capability to use the machine as normal ventilation or using oxygen therapy. So you will be able to choose right now if you want to use a standard ventilation or if you want to use the machine in order to produce high oxygen therapy. As they have different patient circuits, you will be able to go with a complete calibration on the normal ventilation, or you will be able to go to a short calibration if you are going to use oxygen therapy. I'm not going to go in detail on this oxygen therapy calibration, but just let me tell you that the machine during this calibration is just going to check the oxygen concentration and the oxygen supply. And you will be able in a few seconds to be able to start to do oxygen therapy. In normal ventilation, we are going to do a complete calibration procedure that I'm going to show you right now. As soon as you select ventilation, the machine will ask you which type of humidifier you are going to use. If you are going to use an active humidifier or a passive humidifier. Why is an obligation? It is obligated by the machine to select one or another because in a normal ventilation, we are going to use an endotracheal tube. So in normal ventilation, we are going to make a bypass of the upper airways. So we are going to lose all the capability of the body to produce humidity and to warm up the gas that is delivered to the patient. So as we are taking gas from the wall that are dry and cold, we will have to conditionate this gas before going to inside the lung. The goal is to try to achieve 37 degrees here with high 100% of humidity. So in this situation, we have two options. One is the active humidifier, that we are going to use an external device in order to warm up the gas that is going to be delivered to the patient. Here we have the inspiratory limb. The gas that is delivered to the patient go through this humidifier. The gas warm up, and then the humidifier delivery this gas to the patient. Also in the market you may find two different types of humidifier. This example is a closed loop. So you have not only the warm up here, also you have a hot wire inside the inspiratory beam in order to keep the temperature constantly during all the inspiratory limb in order to avoid the condensation. And then the patient will exhale through the expiratory limb to the ventilator. The other humidifier is the passive humidifier. It is passive because you don't need to plug it to any power supply. It is a heat mixture exchange. This device is going to keep the warmth and the temperature and the humidity of the exhaled gas of the patient. So in the next inspiration, the gas is going to go through this filter and it's going to take all the humidity and the temperature that was remained here in the filter and deliver it to the patient. In any of these type of humidifier, inactive and on passive humidifier, we will done a VTPS compensation. What is a VTPS compensation? As you may know, when the gas, any gas is warmed up, the volume of this gas is increased proportionally to the temperature of the gas. Bigger temperature, bigger the volume that is going to occupy this gas. What is happening with the machine or with the ventilators? Normally, the ventilator is delivering a gas that is cold, normally between 20 and 25 degrees centigrade. That this gas is going to go through the humidifier, so the temperature of the gas is going to increase. So the volume is going to be increased, and this volume is going to be delivered to the patient. In order to avoid giving an extra tidal volume that we want, the machine is going to do a VTPS compensation. So the machine, knowing that the temperature at the inspiratory limb is 20 degrees centigrade, is going to do a compensation in order to deliver a lower tidal volume than the one that we have set. For example, if we set 400 milliliters, the machine is going to deliver around 360 milliliters. So when this gas goes through the humidifier, the gas warms up, the temperature is increased, so the volume is increased. The idea of this compensation is to set the volume that we are going to deliver inside the lamp, the same as the one that we have set on the machine. So if we have set 400 milliliters on the machine, the idea is to deliver 400 milliliters inside the lamp. In order to do this properly, we are going to do this VTPS compensation. Let me make another pool. So the question here is, when the VTPS compensation is activated, the delivery of tidal volume from the patient outlet is the same as we have said, lower than we have said, or higher than we have said. Well, was not so easy, or maybe my explanation was not so clear. The correct answer is that the delivery of tidal volume done by the machine is going to be lower than we have said. Why? Because when the machine delivery, I set in the machine 400 milliliters, the machine is going to deliver lower tidal volume, around 360 milliliters. So this 360 milliliters is going to go through the humidifier. So the temperature is going to be increased. So the volume is going to be increased. So this increment that we are going to have in this volume is going to be occupied totally 400 milliliters, the same I have set on the machine. If I don't do this type of compensation, the machine is going to deliver it through the patient outlet 400 milliliters. These 400 milliliters are going to go through the humidifier, so it's going to warm up. The temperature is going to be increased, so the volume is going to increase. So in this situation, if we are not doing any compensation, the patient is going to receive or is going to get from the machine bigger volume than the one that I have set. And this is not a good situation. So in order to avoid to give hyperventilation or give to the patient an additional volume that I don't have set, the idea is to do this BTPS compensation. So the machine is going to make all the adjustment, is going to reduce the delivery of tidal volume in order to guarantee that the tidal volume when it's inside of the lung became the same that you have set on the machine. Once I have set the humidifier, I will go to the second stage of the initial calibration. This second test is going to evaluate different points on different components of the ventilators. It is a very fast test. It takes around 35 seconds to be done. And also it's going to ensure that the ventilator is going to work in optimal performance. If the calibration is done properly without any warning, it means that everything is working properly and we can guarantee that the machine is going to work precisely. Also, using this initial calibration, we are going to be able to use any type of accessory. As I said before, we are going to be able to use adult, pediatric, and neonate patient circuit, disposable, and reusable. It is a calibration that must be done every time that I turn on the machine. If I turn off and turn on the machine, I will have to go through this initial calibration always. In order to do this initial calibration, I will have to block the Y connector. We provide with the machine a cap in order to plug it in the Y connector and to close all the system. You will never use, or you don't have to use, the test lamp. The test lamp must not be connected during this initial calibration. Always block the Y connector and never use a test lamp. If you use the test lamp, the measurements are not going to be done properly. During this initial calibration, the machine is going to make a sensor and valve is going to do a sensor and valve verification. It's going to make a leak test. Then it's going to make a calibration of PEEP, a calibration of expiratory pneumotachograph, a calibration and check of oxygen sensor, and it's going to measure the compliance and the resistance of the patient circuit. It's going to check also all the internal sensors, the sensors that are of air, the inspiratory flow of oxygen, the expiratory flow. Then the second calibration stage of the calibration is the leak verification. The machine is going to check the tightness of the interface. It's going to check all the patient circuit. In this maneuver, the machine is going to introduce pressure in the system. That is why it is important to block properly the Y connector. And then it's going to check if there is any leakage. If there is leakage, the machine is going to show a warning, and depending on the amount of leakage and the patient category, you will be able to continue or not with the initial calibration. For adult and pediatric, this limit is up to 10 liters per minute. So if the leakage on the patient circuit is bigger than 10 liters per minute, we are not going to be able to continue with the calibration. If the leakage is lower than 10, we will have a warning similar to the one that is showing here, saying that the leakage is, in this example, 4.8 liters per minute. And in this situation, you will be able to press the knob and continue with the calibration, or press escape to try to recalibrate. If you continue with the calibration, you will make up this error. So take care. We recommend always to start the ventilation without any error during the initial calibration. But as we know that sometimes there is an emergency, we will allow you to continue with the calibration when the leakage is below this limit. But there are some errors that can appear during the ventilation. If we have leakage during the initial calibration, we may have error on the measurement of the expiratory flow, on the PEEP, and also on the trigger. In neonates, this leak is up to 5 liters per minute. If the leakage is bigger than 5, in neonate category, we are not going to be able to continue with the calibration, and we must solve the problem. If there is leakage, we will have to check all the water traps of the patient circuit. We will have to check the expiratory set. We will have to check if the oxygen sensor is well tightened, and also all the connectors that are there. All the connectors of the patient circuit, of the humidifier, etc. A fast test that we can do in order to check if the leakage is inside of the machine or outside is by doing this kind of short circuit. If we do this short circuit and the leakage disappears, it means that the leakage was in the patient circuit. If the leakage, the message shows even doing this test, it means that the leakage may be inside the machine. Never start the ventilation by doing this short circuit. If we do this short circuit, the machine will not measure properly the type of patient circuit that we are using, and also may have some error during the ventilation. This is only to check and try to figure out where the leakage is. Then the machine is going to make a test and calibration of the expiratory set. This is a very important part of our machine. It is autoclavable, and with the machine comes 2 per device. So the idea of use one of these devices when the other one is in sterilization. As soon as we finish the ventilation, we took the exhalatory valve from the machine and send it to sterilize. We can sterilize by autoclavable, for example. This expiratory set has 2 functioning. One is the valve that is using this diaphragm that is in the cap in order to close and open the expiratory limb during the inspiration and during the exhalation. And also the machine is going to control the PEEP by pressing this diaphragm. The other function of this expiratory set is the flow sensor. This is going to measure the expiratory flow sensor, the expiratory flow of the patient, and is going to measure the expiratory volume of the patient. To do this measurement, there is a thin mylar or lamina between these two hoses, P2 and P1, that is very thin. When the patient exhales, this lamina or mylar is going to move and is going to make a resistance. It is very important to take care of this mylar. If this mylar is not there, the machine will not be able to measure properly the flow. So during the initial calibration, the machine will not be able to measure the volume and the expiratory flow and will not allow you to continue with the calibration. So basically here we have the two functioning. The machine is going to make pressure over the diaphragm in order to close the system during the inspiration, and is going to open the diaphragm during the exhalation, so the patient will be able to exhale through this expiratory set. In this exhalation, the machine is going to measure here the flow exhaled by the patient and is going to calculate the volume. Here, we invite you to go to our website. Nowadays, we have uploaded some short videos that are going to explain how to assemble this expiratory set, how to mount this expiratory set on the machine, and also how to set. So go to tecmeglobal.com, and there you will find all these short videos that are uploaded to YouTube. So you can share with all your staff all this video to see how it's assembled, how to sterilize, and how to mount it on the machine. Always, again, take care of the mylar. Never use sharp elements to clean it up, because you may damage the mylar that is inside. Never use water flow, because also the pressure of the water can damage this lamina. And never blow high pressure air flow inside, because also the high pressure of air can damage this mylar. So during the initial calibration, the machine will check those components. It's going to make a peak calibration, and it's going to check the diaphragm. If this diaphragm is not well positioned or if it is damaged, the machine will give you a warning like this. You will be allowed to continue with the calibration, or you will have to recalibrate. If this warning appears, please take a look to the diaphragm, check it if it is well positioned, check it if it is clean, and also if it is not damaged. Then the machine is going to make a expiratory pneumatograph calibration, so it's going to check the expiratory flow measurement, and it's going to check the mylar. If the mylar is not there, you probably will have an error similar to this one, that you will not be allowed to continue with the initial calibration. So that is why it is very important to take care of the expiratory set. If the expiratory set is not working properly, you will not allow to continue with the initial calibration. If this kind of error appears, you will have to replace all the expiratory set. Then the machine is going to measure the patient circuit compliance and the resistance. This measurement is in order to evaluate with the compressible volume that remains inside of the patient circuit. This is also an important compensation that the machine is going to run in order to guarantee that the volume that we have set on the machine is the volume that goes inside the patient. In order to avoid a remaining of volume inside the circuit, the machine is going to calculate the compliance and the resistance, and it's going to make a customization according to the patient circuit that you are going to use. So if you are going to use adult, pediatric, or neonate, the machine is going to make the measurement of this patient circuit and is going to compensate. And how this compensation works. If the compensation is deactivated, let's suppose that we have set on the machine 500 milliliters of tidal volume. The machine is going to deliver 500 milliliters. In this example, 120 milliliters remained inside of the patient circuit. So the tidal volume that the patient will receive will be smaller. It will be up to 380 milliliters of tidal volume. So in order to avoid this situation in where the patient gets lower tidal volume than the one I have set, the machine is going to do this volume compensation. In order to do this volume compensation, the machine has to measure properly the compliance and the resistance of the patient circuit. This volume compensation is going to work in the following situation. As I said before, in this example, we are going to set the tidal volume of 400 milliliters. In this case, the compressible volume that remains inside the patient circuit is 50 milliliters. So if the compensation is off, the machine is going to deliver 400 milliliters. 50 milliliters are going to remain inside the patient circuit, and the patient will get only 350. In order to avoid this situation, the machine is going to activate automatically the compensation. So as soon as we set 400 milliliters, the machine is going to deliver 450. It's going to add to the tidal volume that you have set the compressible volume of the patient circuit. So in this case, it's going to deliver 450 milliliters. 50 milliliters are going to remain inside of the patient circuit, and just 400 milliliters, the same I have said, are going to deliver it to the patient. So we will not have any loss of volume on the patient circuit. That is important to do the initial calibration with all the interface that I'm going to use during the ventilation. If I'm going to use an adult patient circuit, if I'm going to use a pediatric or neonate, if I'm going to use a humidifier, active or a passive humidifier, must be connected during the initial calibration. So if everything is connected properly, the machine is going to guarantee that the volume that you have set is the volume that the patient will receive. No less, no more. If the patient circuit is not good enough, is too long or is too old and the compliance has been changed and is very high, or if there is leakage, we will find a warning like this one. If during the initial test you found leakage, probably you will get this warning. So you will have a warning of leakage and then a warning of measurement of compliance failed. In order to avoid this error, you have to verify all the patient circuit, remove the leakage and try it again. Also, this kind of warning can appear if we are doing the initial calibration with the test lamp connected. So always remember to do not use the test lamp during the initial calibration. Let me share another pool with you. What happens when the volume compensation is activated? The delivered tidal volume through the patient outlet is lower, is the same, or is higher? Well, here also the same, it was not so clear the situation. The correct answer is that the delivery of tidal volume of the machine when this compensation is activated is going to be higher in order to compensate the loosening of volume that can remain inside of the patient circuit. Here we have again the example. If the volume compensation is on, the machine is going to deliver a higher tidal volume than the one that I have set. I have set 400 milliliters, so the machine is going to deliver it through the patient outlet 450 in order to keep some volume inside the patient circuit and deliver it to the patient the tidal volume that I have set. So the machine in this compensation is going to give a higher tidal volume through the patient outlet in order to guarantee that the patient gets what we have set on the machine. Then the machine is going to check the oxygen sensor. We have an inbuilt oxygen sensor. It is an electrochemical oxygen sensor that is going to measure the oxygen concentration that is being delivered to the patient. So all the gas that goes straight to the patient is going through this oxygen sensor in order to monitorize and show to the user which is the oxygen concentration that is being delivered to the patient outlet. Also, this oxygen concentration, oxygen sensor is going to be used in order to check the quality of the oxygen gas supply. If we don't have oxygen good enough, the machine is going to give us a warning saying that the oxygen is not good or the oxygen cell it is depleted. This oxygen cells, it is electrochemical, so when the oxygen goes through the cells, it's going to produce a reaction that is going to make a voltage. This voltage is going to be proportional to the oxygen concentration. This is like a battery started to discharge. So we recommend to change the oxygen cells at least once a year in order to guarantee that the machine is going to measure properly the oxygen concentration that is delivered to the patient in order to check if the quality of the oxygen that is being supplied to the machine is good or not. If this oxygen it is depleted or the quality of the oxygen supply it is not good, you will find a warning like this one that says that the oxygen cannot be calibrated. You will have to check the oxygen connection, you will have to check the oxygen quality, and also you have to check if the oxygen cells is depleted. In this warning, we are going to be able to continue with the calibration, but we are not going to be sure if the oxygen quality is good enough, and also we are not going to be able to monitorize properly the oxygen concentration. If the oxygen quality is good enough, the machine will deliver properly the oxygen concentration to the patient, but as the cells is not there, we are not going to be able to check if the oxygen is properly delivered or not. So we recommend always to use the oxygen cell in order to guarantee that we are going to provide a good quality of oxygen and also that the machine is delivering properly the FiO2. This is the last test that the machine do during the initial calibration. I show you all the error that can appear. If there is no error, the machine goes straight during the initial calibration and will show you the ventilatory mode configuration. So if you don't have error, it means that the calibration was successful, and you will get this screen in where you are going to be able to set all the ventilatory mode available that depend on the model that you have. Also, let me remember, tomorrow we are going to have a second webinar in where we are going to explain most of the ventilatory mode, how they work, and how to set up all these modes. So again, I invite you to register in the seminar of tomorrow in order to participate and get information on all our ventilatory modes, which are available, and how to set up those ventilatory modes. So now you are going to be able to set up the ventilatory mode, and you are going to be able to start the ventilation. In this screen, this is our interface, where you will find in the lower part of the screen all the settings that are going to change according to the ventilatory mode that I have chosen. So these are the inputs. Then in the center of the screen, I have the graphics in order to monitorize the pressure in the time, the volume, the flow, and the loops. Loop of pressure against tidal volume, and the loop of flow against tidal volume. This is our main screen in where you have 5 graphics in real time. Of course, then you will be able to change this screen in order to see different graphics. Then in the upper side of the screen and in the left, you will find all the monitoring values. You will find the measurement of pressure, peak pressure, trachea pressure, plateau, mean, and peak pressure. And in the upper side, you will find peak flow, expiratory time, ER ratio, rate, tidal volume, minute volume, and oxygen concentration. So as you may see in our main screen, you will find all the basic information to make a diagnosis. The basic monitoring values and also the basic graphics. In the third seminar, we are going to explain a little bit more about all the monitoring values. So also I invite you to register in this third seminar that is going to be done after tomorrow. And we will explain a little bit about the monitorings and the respiratory mechanics. In addition, here in the screen, we will find all the setting of the alarms, the alarm limits for rate, for tidal volume, for minute volume, for oxygen concentration, and the alarm limit of the peak pressure, high and low. And in addition, we have here soft key in order to change the graphics, in order to make a freeze of the screen, in order to get the respiratory mechanics measurements. Again, we are going to talk about this in the third seminar. To save a loop, to activate or deactivate the inbuilt nebulizer, a help key in order to get information of any of these keys that are on the screen and also on the front panel, and the standby mode in order to keep the machine on standby. Again, I remember you the next webinar, the next one tomorrow is going to be done by Emiliano Fontan, one of our product specialists, and we are going to talk about all the ventilatory mode available in our machine. So we invite you to register in our website in order to participate in this seminar. Any question that you may have, please do not hesitate to contact us in technical assistant at tecmeglobal.com. Our team will help you in any kind of question that you may have. So we invite you to email us to this email address. So the webinar for today is finished. We invite you to make your question through the query. We are going to be here replying questions to you. So please do not hesitate to ask whatever you want. We are going to keep this seminar open in order to reply your doubts. Also, if you want to, instead of write them, if you hand up your hand, we are going to activate your mic, and you will allow you to ask personally your question, and we will try to replay those questions to you